going to go over problem 21, and I'm going to show you how to make it really easy with one of these. If you don't have one of these, we'll also talk about how it can be done without it. It's a contingency table showing the relationship between family origin. I don't really like that word race in this situation, but you know, it is what it is. And whether the family borrowed money for college. All right, so our two variables are borrowing money for college and family origin. And so we need to set up a null hypothesis and a hypothesis. Since you already know this is a test of independence, you know that your null hypothesis is going to be that they are independent, that whether a family borrowed money is independent of the family origin. The alternative hypothesis would be that they are not, or that whether a family borrowed depends upon the family origin. This problem also gives us a sigma 0.01. So that means we need to get a p-value of less than 0.01 if we're going to reject our null hypothesis and conclude that borrowing money for college is related to the race or the origin of the family. Okay, so first thing you want to do on your calculator is find that matrix button. You want to go to matrix and edit. All right, and then you want to put into matrix A. So in this case, I'm going to do a 3x2 matrix, right? And then I'm going to put the numbers in the order going left to right, top to bottom. And you can see those numbers in there. So far, so good. Next step is to simply quit. I'm going to go to stat button, and over to the test menu, and up to C. C is the chi-square test. You get observed, expected, and then calculate and draw. It's going to calculate your expected counts for you automatically. So I'm just going to go ahead to calculate, and right away we get our answers. We see our chi-square test statistic is 5.99, a p-value of about 0.05, right? Just under 0.05, but remember our significance level is 0.01, so this is going to fail the test. You can also go to your matrix menu again, so I'm going to go to matrix, and now you should notice that matrix B has automatically been filled in for you. Go straight to 2, and that's going to put that, and I press enter, and like magic, I get all of my expected counts. I'm perfectly fine with you rounding those off to the 10th place. And you can see that I put my observed counts and my expected counts. Now, in order to find the expected counts, if you were doing that by hand, remember that you need the totals for the columns and the rows, and then what I call our grand total right here. Okay, to find the expected count for this first cell, I would take this total, 113, times 219, and divide it by 586, and that should give you about 42.2. All right, if I want to find this one over here, I take 208 times 367 and divide it by 586. Right, so you're always taking the column total times the row total and dividing it by the total, and that will give you your expected count. If you want to get the chi-square statistic without using the calculator to cheat, then you're going to have to use that formula, observed minus expected squared divided by expected. So in other words, to get the contribution for this cell, I would take 49 minus 42.2, get the answer, square that, get the answer, and then divide by 42.2. And I get about 1.10. So for this one right here, for example, I would do 123 minus 130.3. It's going to give me a negative number, right? But when I square that, it's going to be positive. And then I'm going to divide by 130.3. And I think that one should be 0.41. Of course, I have to do that for all 6 of those cells, add them up, and that gives me my chi-square, which in this case I got about 6.01. And to find my p-value, I need to know my degrees of freedom. Remember the degrees of freedom, if I take out one of the rows and I take out one of the columns, I'm left with just 2 cells. Gives me a degree of freedom of 2. You can see I got a p-value here also of 0.0496. I went to my handy dandy TI and distribution menu, and you go to chi-square CDF, and your lower value is going to be your test statistic, in this case 6.01, and your upper value, however many 9s you're feeling today, and your degree of freedom is 2. You see I get my 0.0495. It is greater than our significance level of 0.01, which means what? That we fail to reject our null hypothesis. Okay, now again, if you don't have the calculator, go to the link on that last video and you can use the chi-square calculator on the link that I gave you. So if our null hypothesis is that borrowing is independent of race, what does it mean to fail to reject that? Our conclusion, we should state something like, because our p-value is greater than our alpha, we fail to reject that borrowing is independent of race. We don't have enough evidence to conclude that whether people borrow for college is dependent upon their race or ethnic identity. All right, if you have any questions, comment below or email me. And hold on, somebody's here to see you. And that is Mr. Brain. Yes, Mr. Brain misses you guys. I don't, but he does. And Mr. Brain is very proud of the graduating seniors. All right, so guys, stay safe and look for information on my website, miller.mathevolution.com.